Welcome to DRM News Podcast. Astronomers are tracking an asteroid. You know, a kind that makes headlines, called 2024 YR4. And there's a slight chance, very slight, that it could impact Earth in 2032. But before you start prepping that underground bunker, let's break down what we actually know. Okay.
You're right to caution against panic. A 2.3% chance of impact, while worth monitoring, is still incredibly low. Think of it this way. You're far more likely to win a small lottery prize than see this asteroid anywhere near our planet.
That puts things in perspective, for sure. So tell me, what makes this 2024 YR4 so special that it's on our radar at all?
Well, it was discovered just last December by the Asteroid Terrestrial Impact Last Alert System, ATLS for short, down in Chile. And based on observations so far, it's estimated to be somewhere between 130 and 300 feet across. Imagine a football field-sized rock hurtling through space.
Okay, I see why we're paying attention now. But how do they even find these things? There's a huge universe out there.
It's like looking for a needle in a haystack. But instead of a haystack, it's the vastness of space. We rely on a global network of telescopes that constantly scan the night sky, searching for anything that moves against the backdrop of stars.
So anything that's zipping around more than the usual background stars, that's a red flag.
Exactly. Closer objects appear to move faster across our field of view, which is how we initially flag potential near-Earth objects, NEOs for short. Then we use a combination of optical and radio telescopes to nail down their size and trajectory. It's a bit like detective work.
Now, you mentioned the odds of impact have actually gone up since 2024 YR4 was discovered. It sounds a bit ominous, doesn't it?
It can sound alarming, but it's actually pretty standard. Think of it like trying to predict where a hurricane will make landfall.
Yeah.
The initial cone of uncertainty is pretty wide, but it narrows as we get closer to the event and gather more data. The same applies to asteroids. As we get more observations, those initial probability calculations are refined in almost all cases. The risk actually goes down to zero as our understanding of the asteroid's path improves.
So, more data is actually a good thing, even if it temporarily bumps up the percentage.
Precisely. It means we're getting a clearer picture. And speaking of getting a clearer picture, we have the James Webb Space Telescope set to observe 2024 YR4 in March 2025. That will give us incredibly detailed information about its size and composition.
That's amazing.
Yeah.
But I'm guessing there's a catch. We can't just point the James Webb at anything we want.
Right. You're right. There's a limited observation window.
Yeah.
And unfortunately, after that, we won't be able to get a good look at it again from Earth until June 2028. So the data we collect in the next few months is absolutely crucial.
Okay. So let's say worst case scenario happens and this asteroid really is headed for us. What are our options? I mean, can we actually do anything to stop an asteroid? Is that just Hollywood stuff?
Not anymore. Remember NASA's DART mission? They intentionally crashed a spacecraft into an asteroid and successfully changed its course. It was a pivotal moment for planetary defense, proving we have the capability to protect ourselves from these kinds of threats.
That was such a cool mission. It felt like something out of a movie. But it worked.
It was a groundbreaking achievement, of course. There's still a lot we're learning about asteroid deflection. Success depends on many factors, including an asteroid's composition and how much warning time we have. A loose collection of space rocks would react much differently to a kinetic impactor than a solid chunk of metal. For example.
So, what are agencies like NASA doing to prepare for potential asteroid threats? Are we ready for whatever the universe throws at us?
We're getting there. They're constantly working on improving detection capabilities, developing new deflection techniques, and even considering options like gravity tractors, which use a spacecraft's gravitational pull to nudge an asteroid off course. It's a whole new world of scientific exploration and planetary defense.
This is fascinating stuff. We've covered a lot of ground already, but I feel like we're just scratching the surface.
We are. And in the next part, we'll delve deeper into how astronomers track and characterize these celestial wanderers, taking you behind the scenes of their amazing work. Picking up where we left off. Let's imagine one of those telescopes spots something moving a bit too quickly for comfort. What happens next?
Yeah, that's what I'm wondering. Do alarms start blaring? Is there a red phone that gets picked up? What's the procedure?
It's a bit less dramatic than that, thankfully. The first step is to compare the object's position and movement to a vast database of known asteroids and comets. Astronomers have been tracking these objects for centuries, so chances are it's something already on their radar.
So, kind of like a cosmic fingerprint database.
Exactly. But if there's no match, well, then things get a little more interesting. That's when follow-up observations become crucial.
More telescopes, more data.
Exactly. They'll use multiple telescopes to confirm its movement, refine its trajectory, and get a better handle on its distance from Earth.
Okay, so how do they measure the distance to something that's millions of miles away? It's not like they can just pull out a giant tape measure.
You'd be surprised at how accurate our cosmic measuring tools are. Radio telescopes play a big role here. By bouncing radar signals off the asteroid and measuring how long it takes for those signals to return, we can calculate the distance with incredible precision.
So, like a super high-tech version of sonar.
A very good analogy. And once we know the distance, we can start to estimate the asteroid's size, which is obviously a big factor in determining the potential threat level. A tiny pebble isn't going to cause much damage, even if it does hit us.
That makes sense. But I'm guessing size isn't the only thing that matters. What about what the asteroid's made of? Does that play a role?
Absolutely. A dense, metallic asteroid is going to behave very differently than a porous, rocky one, even if they're the same size. So figuring out composition is key.
Yeah. How do they do that? Are we sending probes out to collect samples?
While we have done sample return missions, those are incredibly complex and expensive. More often, we rely on a technique called spectroscopic analysis.
Okay. I have to admit, that one's going over my head a bit. Break it down for me.
Think of it this way. Different materials absorb and reflect different wavelengths of light, creating a unique spectral fingerprint. By analyzing the light reflected by the asteroid, we can determine its composition without ever having to touch it.
So, it's like each element has its own light signature.
Precisely. It's a powerful tool that gives us a wealth of information from millions of miles away.
That's amazing. So now we've got the distance, size, and even what it's made of. How do they use all that to figure out if it's actually going to hit Earth?
That's where the magic of orbital mechanics comes in. Scientists take all that data and use complex calculations based on the laws of gravity and the asteroid's observed motion to project its future path.
So it's like plotting a course for a ship. But instead of winds and currents, we're dealing with the gravitational pull of planets and stars.
A great way to think about it. And remember, these calculations are constantly being refined as we gather more data. Even a tiny change in trajectory early on can make a big difference years down the road. That's why continuous monitoring is so important.
So it's not a set it and forget it kind of situation.
Not at all. It's an ongoing process of observation, calculation, and refinement. And it involves a global network of scientists working together, sharing data and expertise.
It's a global effort to protect our planet. That's pretty inspiring when you think about it.
Yeah.
But let's face it, the question everyone has is, what happens if one of these things actually does hit us?
That's a sobering thought, and one we can't ignore. The effects of an impact depend on a lot of factors, like the asteroid's size and composition, but also where it hits. An asteroid splashing down in the middle of the ocean is very different from one hitting a major city.
Right. Because we've all seen those disaster movies where an asteroid triggers massive tsunamis. Is that a real concern?
Absolutely. An ocean impact could create tsunamis that travel thousands of miles, causing widespread devastation in coastal areas.
Now, on top of that, there's all the dust and debris that would get thrown up into the atmosphere.
That's another major concern. Especially with larger impacts, that debris cloud could block sunlight, leading to a global cooling effect that could disrupt agriculture and ecosystems. It's a cascade of potential consequences, and it's why planetary defense is such a critical area of research.
I have to ask, are smaller impacts more common than we realize?
Much more common. Earth is constantly being bombarded by small particles from space. Most burn up harmlessly in the atmosphere, creating those beautiful streaks of light we call shooting stars.
Wait, so those shooting stars we wish on are actually tiny pieces of space debris?
Exactly. It's a constant reminder that we live in a dynamic solar system, and these encounters are part of our planet's history.
This has been incredibly insightful. We've gone from searching the skies for these asteroids to understanding their potential impact. Literally.
It's been a fascinating journey, but the story doesn't end there. In our final part, we'll explore the strategies being developed to deflect or even destroy potentially hazardous asteroids. We'll talk about the future of planetary defense and what steps are being taken to safeguard our planet.
Welcome back to DRM News Podcast, where we've been taking a deep dive into the world of asteroids, specifically one that's on astronomers' watch list, 2024 YR4.
We've covered how these space rocks are discovered, tracked, and even what could happen if one decided to pay Earth a visit.
Right. And now for the question everyone's been asking. What can we actually do if an asteroid has Earth in its crosshairs? Do we have any options beyond, just hiding under our desks.
Thankfully, we've moved beyond the duck and cover era of planetary defense, and we're not just talking theory anymore. We have actual proof that we can deflect an asteroid.
You're talking about NASA's DART mission.
Right.
The one where they sent a spacecraft on a collision course with an asteroid.
Exactly. The Double Asteroid Redirection Test, DART for short, was a historic mission. It showed us that we can deliberately alter an asteroid's trajectory. And while the target, Dimorphos, was relatively small, the implications are enormous.
It's like something out of a science fiction movie. But it actually happened. We can nudge these things off course. That's a huge relief.
It's a significant step forward. But it's important to remember that there's no one-size-fits-all solution. Each asteroid is unique, with its own size, composition, and trajectory. What worked for Dimorphos might not work for another asteroid.
So what other options are we exploring? What's in the planetary defense toolkit, so to speak?
One intriguing concept is the gravity tractor.
A gravity tractor. Okay. Now that sounds like something straight out of Star Wars.
It does have a certain sci-fi ring to it, but the concept is based on solid physics. Imagine positioning a spacecraft near the asteroid and using its gravitational pull, albeit very slight, to gently tug the asteroid off course.
So it's like a cosmic game of tug-of-war, using gravity as the rope.
Exactly. It's a slow process, requiring years of lead time. But it could be very effective for even large asteroids. And since there's no direct impact, there's less risk of fracturing the asteroid into smaller pieces.
Pretty clever. What other options are there?
Another promising area of research is using focused solar energy, basically. We'd use a large mirror to concentrate sunlight onto the asteroid's surface, causing material to vaporize and create a jet-like thrust, altering its path.
It's like using a giant magnifying glass to create a mini rocket engine on the asteroid itself.
That's a great analogy. It sounds futuristic, but the technology is already being developed and tested. And then, of course, there's the option of nuclear explosives, though that would only be a last resort for a truly catastrophic threat.
Nuclear bombs in space. Isn't that a bit risky?
It's definitely a controversial option, and it would only be considered in the most dire circumstances. The idea isn't to blow the asteroid to smithereens, but to detonate a device near it, creating a shockwave that nudges it off course or breaks it into smaller, less dangerous fragments.
More about deflection than destruction.
Exactly. But even in that extreme scenario, there are a lot of factors to consider. The size and composition of the asteroid, the precise timing of the detonation, and the international implications of using nuclear weapons in space.
It's a complex issue.
With scientific,
Ethical.
and political dimensions.
Absolutely. But the key takeaway is that we're actively researching and developing a range of options for planetary defense. It's not just about knowing that the threat exists. It's about having the tools and strategies to protect ourselves if and when that threat materializes.
It's like having a fire extinguisher in your kitchen. You hope you never have to use it, but it's there just in case.
A perfect analogy. And just like with fire safety, early detection and preparation are crucial. The more warning time we have, the more options we have for dealing with a potential asteroid threat.
So how would you assess the current state of planetary defense? Are we ready for whatever the universe throws at us?
We're making significant progress, but there's always more work to be done. Agencies like NASA and the European Space Agency are investing heavily in planetary defense research, developing new technologies, and improving detection capabilities.
Yeah.
But we can't be complacent.
What are some of the biggest challenges we still face? One of the biggest challenges is simply finding all the potential threats out there. While we've identified many near-Earth objects, there are countless others that remain undetected. And we're still limited by our ability to detect asteroids coming from the direction of the sun.
So there could be a planet killer lurking out there that we haven't even seen yet.
It's possible, but statistically unlikely. The good news is that larger asteroids are easier to spot. But we need to continue improving our detection capabilities, both ground-based and space-based, to close those gaps.
And once we do detect a threat, we need to be able to act quickly.
Exactly. Developing and launching a planetary defense mission takes time, especially for more complex techniques like gravity tractors or solar deflection. International cooperation and a clear plan of action are essential.
It sounds like we need a global planetary defense task force, ready to mobilize at a moment's notice.
That's not far off from what's starting to emerge. Organizations like the International Asteroid Warning Network are fostering collaboration and communication among scientists and space agencies worldwide. It's a step in the right direction.
So we're not quite there yet, but we're on the right track.
I believe so. Awareness of the asteroid threat is growing. And we're seeing increased investment and political will to develop the tools and strategies we need to protect our planet.
It speaks to human ingenuity and our collective desire to survive and thrive.
Exactly. And it's not just about avoiding disaster. It's about pushing the boundaries of science and technology, exploring our solar system, and securing a future for humanity among the stars.
On that inspiring note, I think we'll wrap up our deep dive into Asteroid 2024 YR4 and the fascinating world of planetary defense. It's been an incredible journey.
It has. And to our listeners, we leave you with this thought. As we venture further into space, planetary defense becomes not just a scientific pursuit, but a fundamental responsibility, ensuring the safety and future of our planet and our species.